Hi everyone, welcome to our 6.3 lesson. We're going to start now at graphing some systems of linear inequalities, and figuring out from the graph what the solution set is. Okay, so we're in our 6.3 notes. Solving a system means to look for the solution. Okay, when you have a system of linear equations, it means to look for the point where they cross, those two lines cross. When we solve systems of linear inequalities are a little different than an equation because they have an inequality sign instead of an equal sign. We must graph each inequality and then find where those solution sets overlap. Remember, when you graph an inequality, not only do you have to graph the boundary line, but you have to shade one side. So we're going to be looking for where those shaded regions overlap. And we're also going to be asking ourselves if the point of intersection of the two boundary lines is also a solution. So let's do one as an example here. Example 1, graph the solution set for the following system. And then at the end, we'll choose two possible solutions. There will be probably many solutions, but we're just going to choose two. Okay, so let's have a look. We've got, let's call this inequality 1. And I'm going to use blue here and call this linear inequality 2. So I can tell right away I'm going to have two lines on my graph. And I can go ahead and start to think about how I'm going to graph those. The first thing I should recognize here is if I'm not given any information about whether these are real numbers or whole numbers or natural numbers, then I can assume that they're real numbers. Okay, so if you're not told that they're integers or whole numbers or natural numbers, we're just going to assume that they're real numbers. So we're going to assume there's no restrictions here. Okay. So I don't see anything given to me, so there's no restrictions stated. Okay, which tells me a little bit about the possible values of x and y, the domain and the range. I'm going to assume, okay, that x is a member of the real numbers and y is also a member of the real numbers. So this is continuous data that I'm graphing, which means that I'm going to have what's called a continuous solution set. In other words, once I figure out where these two inequalities overlap, that shaded region where they overlap, I can say that all the real numbers in that shaded region are solutions. Okay, let's go ahead and start rearranging these so that we can graph them. I see that my first linear equation that I have, so let me rewrite them for you right here. In your notes, you can rewrite them just down below. Okay, I have this 3x plus 2y, okay, is greater than negative 6. Before I can go ahead and graph that, I know right away I'm going to have to do some rearranging because it's not in slope-intercept form. Remember what slope-intercept form is. Okay, y is, when you do the boundary line, it will be y is equal to your slope times x plus your y-intercept, b. Okay, if you right away look at this linear inequality, I recognize that there's my b, negative 6 is my b, there's the number all by itself. There's my y, but it's right now it's being times by 2. I'm going to have to deal with that. And there's my slope. There's my mx right there, 3x. Okay, so we need to get this inequality into slope-intercept form. So I need to move my 3x over to the other side. So I'm going to export it over or subtract 3x from both sides. I'll leave the y where it is and the inequality sign there. And I have now negative 3x on the other side, but I'm going to put that in front of the 6. Okay, so negative 3x, and then I've got minus 6 there because it was a negative 6. I'm almost good to go. I have to deal with this 2 on the y. It's 2 times y. I need to have y all by itself, just like it is in slope-intercept form. So I'm going to divide by 2. I'm going to divide everybody by 2. So 2 divided by 2 gives me y. Y is greater than negative 3 over 2. There's my slope. X minus 6 divided by 2, which is 3. Okay, there's my first inequality that I'm going to graph. And before I even graph it, I can already decide what kind of line it's going to be and whether I'll shade above or below. Remember that your inequality sign tells you all that information. I have a strict inequality. There's no equal sign under that inequality sign. That tells me to use a dashed line for my boundary. Okay, it also tells me to shade. Because it's greater than, I'm going to shade above the boundary line. Okay, so I already know how that's going to look before I even graph it. The second linear inequality that I have to graph was given to us, and it was y is less than or equal to 3. Okay, I don't have to do any rearranging here. It's already, there's nothing I can do to simplify this further. But what I do recognize is that this is going to be a horizontal line that goes right through the point y equals 3 on the y-axis. Okay, so that's going to be just a horizontal line right through there. Again, I look at my inequality sign because that gives me a lot of information on what that line is going to look like. Okay, I have this time I have a equal sign underneath the less than sign. So that tells me this is going to be a solid line. And the less than tells me to shade below that line. Okay, so I'll shade, in other words, everything that's less than 3. Okay, I'll shade below. So let's go ahead and graph that. You've got some graph paper on your next page. I'm going to use, again, I'm going to graph my 2 boundary lines. So here's my first boundary line. Okay, well, the first inequality that I'm going to graph is going to be y is greater than negative 3 over 2x minus 3. So there's my first inequality to graph. I'm going to start at negative 3 because that's my b value. Okay, so we're right down here at 1, 2, 3. That's where I start this graph. That's a solid dot at negative 3. And then my slope tells me to go down 3 and over 2. So down 3 and over 2. And I'm going to put another data point there. And then I can do another one. Down 3 over 2. I'm going to go ahead and go in the opposite direction and finish this line. Please make sure you can use your ruler. Okay, that works as well, but I don't have a ruler, so I'm going to continue my data points. If I want to go backwards, reverse, I'm just going to do the reverse of the slope. So I'm going to go up 3 and back 2. Put a data point. Up 3, back 2. Up 3, back 2. Okay, there's enough points there. Now I can connect them with my dashed line. Okay, remember we said that will be a dashed line because it's a strict inequality. That dashed line that I just drew is the line. I could come up here and just write that. The boundary line that I just drew was y equals negative 3 over 2 x minus 3. That's what I just graphed, that boundary line. Okay, when you do a boundary line, it's okay to put an equal sign there because we haven't, we're just saying that's the line that I graphed. Okay. Now I need to decide whether to shade above or below, and we went and looked at our inequality sign. It was a greater than sign, so it tells me to shade above, so let's go ahead and do that. Okay, so shading above. All right, I'm going to do the next one, and that's y is less than or equal to 3. So I'll start by doing my boundary line. The boundary line is the line y equals 3, and it goes right through 3, which is right here on my y-axis. So this is going to be a solid line that goes all the way through. Okay, and that boundary line that I just drew just now, I could label it right there. It's y equals 3. That's the name of the boundary line. And I'm going to shade below, so everything below it. Okay, so I've gone ahead, I've graphed it. The next thing that I want to do here is decide what my solution set is. There's a couple things I need to mention. The first thing I want to mention is that when you have a dashed line, whenever you have a dashed line, for that linear inequality, so in this case our red dashed line, okay, I know that there's no solution possible on the dashed line. The only solutions for this red inequality would have to be above that line or or in the upper plane that I had shaded. But there's no way that I can have a solution on the dashed line because there's no equal sign under that inequality sign. So that means that when you graph a system where my blue line crosses my red line here, right at this point right here, okay, if you look on your graph, that is the point -4 for x, +3 for y. That's the point -4, 3. That point of intersection is not a possible solution. Why? Because it's the point of intersection of a dashed line with a solid line. If they were both solid lines, that point would be a possible solution. But anytime you have one or more dashed lines, we have to use an open data circle or an open data point. Okay, so in your notes there, it says I must use an open data point here. I must say that that point -4, 3 is not a possible solution. So I would just take my eraser and I would erase the point of intersection and put an open circle right there. Okay. Okay, the second thing I need to do is figure out where these two overlapping regions overlap, or where these two shaded regions overlap. Well, I can see that I shaded everything above the red line and everything below the blue line. So the place where they overlap is going to be below that blue line and above that red line. Okay. And so I can now take my pencil or your pencil crayon, and I'm now going to shade that entire region where those two shaded regions overlap. Okay, that is my solution set. I just figured it out. Okay, so I found the overlapping region. And what can I say about all the possible solutions? Well, a solution that satisfies both these linear inequalities can either be in this yellow shaded region, okay? It could also be along the blue line, okay, up to the point -4, 3. That's not a possible solution. And that's it. It cannot be on my dashed line, okay, but it can be above my dashed line and on or below my blue line, y = 3. I can use words to describe that, and that's what we're going to do. So we're going to say the solution set is, okay, on or below y = 3, and above the line y = -3/2x. So above the line y is equal to -3/2 x minus 3. Okay, so it's on or below my solid blue line and above my dashed line. That's my solution set. To pick any 2 points in this solution region, you can pick any points at all. This is real data, so you could pick any points you wanted. You could pick a point right here. That's in the solution set. Okay, you could pick a point anywhere in this region, just as long as you're not picking a point on the dashed line. Okay, can't pick a point in there. But I could pick, say, this point right here. Okay, well, let's see what are the values of that point. It's at 4 for x, and it's at +1 for y. That's definitely a solution. Okay, I could pick any other point in here too. For example, I could pick this point right here. Okay, so it could, let's figure out the coordinates of that point. That's at 3 for x and -2 for y. Okay, so if you're asked to pick just 2 solutions or 3 solutions, that means pick any point in the solution set. Okay, just be sure that it is in your solution set. You couldn't pick a point up here, okay, or over here, because they are not in the solution set. Okay, so below on your notes, you could go ahead and pick any 2 points that you like. Okay, so in our case, what did I pick there? 4, 1, and 3, -2. Okay, but any points at all that are in the shaded region are acceptable. I'm going to stop this right now, okay, and I'm just going to carry on in a separate video. I just have to keep it under 15 minutes. So please pause now and join me in the next video.